So, in this session, we will talk about the exception handling. What's the meaning of the exception handling? Firstly, we need to talk about that, okay? In runtime, there may be some errors, such as zero division error or reaching the unknown address, or etc, etc. For example, if we have any data with the values of the 1 and we want to divide it to the 0 value, it goes to the infinity. In computer architecture, this is an error, but it's a runtime error. And so, in order to catch this kind of errors, we can use the exception handling mechanism, okay? And it's called the exception, in which it can catch these kinds of errors, okay? In Python, the basic syntax is given with the try keyword, like this one, and so we should give the suite in here, or statements, and after that we can write the except keywords with the type of the except keywords as a class, and then we can assign the type name in here like this one. And also we can give the another type of the exceptions type as with the type name, okay? We can reach the information of the exception parameters in here. And also we can give the some statements. After that we can give the finally keywords. If we catch an error in here, and then we can give the some basic structure or the parameters to finalize your process, okay? This is the basic syntax of the exception handling mechanism in Python programming language. In order to understand the utilization of this mechanism, we should give some examples like this one. Firstly, we can assign the x to the 0 value, and while x is not equal to the 1, and we can write the try keyword in here as input parameter, give a value like this one. After that, x can be converted to the s if it is in the type of the is in the type of the number, not as string values, okay? And so we can print the s. But if we write the except value error, and so we can print this is not a number, okay? And in this code, the print program is end. Okay? So, if I run this code, and then we can give the 5.5 value, and voila, this s is not with the this is not a number, okay? But this input is given in here. This exception is occurred, or this one, or this one, or this one, even if this term is here, okay? So this value error as always given in this notation, in this class structure, and the value error is always given at this time. So this is the case. Can create another properties in here like this one. We can create the def foo function and return to the 10 plus Ali. This is not the case because this is an error case, but in syntax we can add these two terms. But if I write the print, the enter the try statement in here, and foo can be called, okay? And after that we can give the accept value error like this one, print value error is occurred or occurs, okay? Accept type error, print type error occurs, okay? And after that we can continue with this code. So if I run this code, the type error can be given in here because this is not a value error, this is a type error, like in the first case, okay? And so this type error is given in here, and we can catch the whole the times of these terms. But if I remove this code and show the type error, unsupported operand type for plus equal into str cannot be converted to each other, which means that if we don't have any exception block in here, and then our program is collapsed, okay? So we need to give the whole the try catch blocks in here like this one, and then we can continue to programs. But if we don't have any keywords except the type error, and then our program is end or broken, okay? This is important topics of the catching the errors in here, and also if the program is run, and then we need to give this try catch and accept keywords in here like this one, okay? Otherwise our program is ends. But in this case, if we have the try accept blocks in here, and then our program continues to the other operations, okay? So in another example, we can give the print values in here like this one. The foo begins, and bar can be called, and print foo end, okay? And we can define the bar function in here like this one. The bar begins, and the integer xxx, this is a error in here, this is the value error, and bar ends, okay? So if we call the foo function, and then we will have the error, the email literal for integer conversion type with the base 10, which means that the xxx cannot be converted to the integer one. But if I have the try and catch block, try and accept block, with the exceptions of the value error, print value error occurs like this one, and also we can give the type error, and also we can give the index error, like this one. The program continues its operation by catching these terms. Foo begins, bar begins, and value error is occurred in here, and then the program jump to what? To the this state or this print function, okay? It's not a collapsed case, but only if we use the try and accept blocks, okay? In the for example, can define to this structure, def foo and def bar, but in this case we can create the try catch block, the foo function like this one, except we can give the tuple values for this class parameter like this one. In each case, we have the what the value error and type error can be cached by using this classification. Okay, and so we can print the what the value error and or type error are cached. Okay, or we can give the only one index error parameter in here, like this one, the print index error exception. And after that we can give the what the continue operation, like this one. Okay, and so we can give the one exception to the what the many type error or type error class, like this one. This is the basic syntax of the Python programming language. So if we catch the whole error without using the any type declaration function, we can use the another property or the another definition, like this one. In the try block we can call the foo, and only we can say the except, like this one. We can print the what the an exception occurs. Okay, and we can print the continue in here, like this one. And so we can assign or we can cache the whole the parameters or the errors, but a plus a2 a can be given in here, like this one. This is the syntax error. Just remember that. Okay, if you have the any definition that the utilization of the syntax rules, and then we have the syntax error, this try and except blocks cannot be catch this kind of errors, but this foo can be assigned with the what with the true syntax, and then we can catch the whole the runtime errors by using these terms. But this except is only using the this except keyword, and then this except can catch the whole kind of runtime errors by using this syntax. Okay. So next 6. For example, if you have the def banner text parameter, if not is instance text in the type of the str, and we can raise or throw the type error function in here. Otherwise we can write the what the this score term with the what the len of text. Okay, and also we can give the what the print text value in here, like this one. And so banner can be called with the ankara, like this one. And so we have the ankara. But if the banner is not equal to the str type, and so this raise type error is throwing from the what from the program or the Python programming language. This raise keyword is utilized to what to throw the any type of error in the what in your code, because the program must be broken or must be stopped with the what with this raise operation. But in try and except blocks we can continue to the other process, but in this case we cannot. Okay. So how about the utilization of the type name in exception blocks? We can define the def bar a in here, and bar begins can be given in here. Okay, and so if it not is instance, a is or is not type of the int, and then we can raise the what the type error, not integer. Okay, so if a smaller than 0 and raise value error, the number is smaller than 0, This is not the error case or the runtime case, but you can specialize the specific function or the specific property to the what, to R or to your class or the functions. Okay, in the syntax we don't have the any error with the definition of the a, because a can be what, the -5 or -10, but in your application maybe this is the value error, and so you can specialize whole this function by using these terms like this one. Okay, and so the bar ends in here, and also we can define the def foo function, print foo begin, bar a can be called print foo end. Okay, so in the try block, firstly 10.5 can be given, and we can give the except block type error as e, like this one, and so we can assign to the what, this type error with the what, with the e, which means that we can reach the this information by using the these terms. Okay, and so we can learn the what, the exception type of this what, e arguments 0 value. Okay, or we can assign to what, to e with the value error like this one, and so we can reach this code, or we can give the final codes in here like this one. The program is end, because the each case is performed before the what, before the final. Okay, and so if I run this code and foo begins in here, the bar begins in here, and so this exception not int is given with the what, with the raise of the type error, and so this e can be assigned or can reach this to the what, to not int specialized characters. Okay, or we can give the what, the -1 in here like this one, and so the exception is throwing by the program the number is smaller than 0. But in normal case we don't have the any errors, or we don't have the any errors condition about the what, the -1 or -2, but in your application maybe it's the some kind of collapse process. Okay, so before this definition we should give the what, the another term. We can create the my error class with the what, with the driving from the what, exception class. Okay, we can specialize this class like this one, a integer value input, give a value term in here like this one, and so if a is smaller than 0, and raise my error constructor. Okay, because it's derived from the what, the exception class, which means that the my error possesses the whole the function or the methods or the attributes of the exception class. Okay, and after that we can multiply the a times a, but we should give the except keyword like this one, the value error. This is the what, the print, this is not a number. Okay, or except my error at now can be given to this case like this one, the print the number is negative, for example. And finally we can give the print the finally block. Okay, and so if I run this code and give a value 5 and 25 is given and final block is run. Okay, but if we have the -1 and number is negative and final block is always calling here like this one. But what about the program ends is given in here, and so if we have the -1 and so this final block is run after before the print program ends. Okay, just remember that. We can create our own classes by using these terms to throw the exceptions. So there's another important topic about the with keyword in what in Python programming language. Okay, we need to give the definition of the with keyword in Python. Automatic resource or the source elimination can be done to the any variable by using this with keyword. In C# using keyword is identical with this keyword, and the basic syntax can be given with what the with, and we can give the any statement in here like this one as variable name. Okay, it's the basic syntax. After that we should give the double dot, and so the suite can be added in here. This is called the context management protocol in Python programming language. And so what's the purpose of utilization of the with keyword? With keyword is always utilized to the resource allocation or the elimination in the process. For example, if we create any variable with the usage of the with keyword, and then we can terminate or remove this variable in the with keywords automatically. And so we don't need to delete or remove any keyword defined in this definition like this one. Okay, so how can we create the patterns or the class by using this with keyword? With keyword is the overloading mechanism in the class structures. For example, if we have the class sample in here like this one, def init can be called by using these terms, and then what the print init func can be given. Okay, we have the two specialized the function self parameter in here like this one. The enter function is the constructor of the with keywords, and def exit function is another term like this one with the three types of the executable type, executable value, and the trace back can be given or should be given to these terms. And so this print the exit func is called by using these terms. And also we can give the another function, display function, print disp function. Okay, so print begins can be given in here like this one, and so the with sample as s can be defined in here, which means that the enter function should be called in here like this one in terms of the sample. Okay, and the print suite can be added in here, and after that the print ends must be given. And so after this code is run, and then the exit function is also called by the programs. Okay, the begins init func is creation of the sample object. The enter func is related to the with utilization keywords, and after that the suite is run, and at the end of the with sample as s code, and then we should call to the exit func in here like this one automatically, and then this prints ends all the codes in here. So what's the point of utilizing this with keyword? This with keywords always utilized to the file opening and reading process. Okay, for example, if we have the any class like this time file wrapper. Okay, and so def init can be given in the path, and the self file is the open path w writing mode. Okay, and so def write self s can be given in here, self f write can be called with the s to write this operator. And also we should give the close function in here like this one. We should always close the opening file in Python, but if we have the enter methods in here like this one, the self and this prints enter func. It's the creation of the return self parameter, but in the exit body or exit function we can automatically remove this close function, self executable type, executable values, and trace back should be given, and after that the self f close should be called, and print exit func should be given and return to the false value, because we should give the close parameter to terminate all the codes. Okay, and so if we have the try catch block in here like this one with file wrapper function with the test.txt sf, and then the enter function is calling. After that the file write, this is a test, okay, and the except keyword in here print file IO error. Okay, so if I run this code and then the enter func and exit func is calling, which means that if we create any opening file operation, we don't need to use the def close function, because this close function is given in the exit function, and so this enter function creates this term and exit function creates the closing operation. For example, the test.txt, this is a test function, or the written object is written like this one. But if I remove this code, also the pass can be given in here, and the enter func can also be written like this one. Enter function can be called. Okay, so if I run this code and then this test.txt is changed with the definition of the enter function can be called, which means that this creation calls the enter, and enter is always to write these terms, or the opening file or the file operations is started. This is the warning of our file wrapper function. Okay, and so this test file is indicating at the first place that the file operations is started. This is the warning, or the first case of the assigning to the other operators to this mechanism. Okay, this is the utilization of the with keyword in C, in Python programming language. Okay, any question?